Hello guys, today I'm going to make a video that shows how to draw dot and cross diagrams when they ask you in the exam. I know many of you guys have the chemistry exam for Oxford AQA that is tomorrow. So hopefully this video should help. So if they ask you how to draw the structure of sodium chloride, so in order to do this, firstly I would like you guys to find out what sodium is. What's the atomic number of sodium? So in your periodic table, which is given in the exam, remember to take black pens along. So you have sodium, which is Na, and its atomic number is 11. Remember, an atom's mass number is always larger than its atomic number. Okay, so it's 11. We know that the first shell contains 2 electrons and the second shell contains 8. So in this case, it's going to be 8 and 1. So in order to draw that, that's done. Then in chloride, we know that it's a chlorine atom. Okay, so in order, we just find out the atomic number of chlorine. So in this case, chlorine has an atomic number of 17. So in order to do this, the first shell is 2, second shell is 8, and the third shell should be 7. Remember that the first shell consists of 2 electrons, the second shell 8 electrons, and third shell has a max capacity of 8 electrons as well. So once you're done with this, you need to draw the dot and cross diagrams. So now it depends on how you're drawing it. Now if you're drawing for an individual sodium atom, you can use crosses, but if you're drawing for 2 atoms, one has to be a cross and one has to be a dot. So now in this case, sodium, I'm just going to put a circle around sodium itself, and this should show the electronic transfer diagram. So it doesn't matter if you show the other electrons, you just show the arrangement of electrons in the atom or ion, and in this case each electron is represented by a dot or a cross. So these diagrams have to show which atom the electrons in an ion originally came from. So in this case we have sodium. So you can just draw sodium's atom with the dots and crosses. So I'm just going to use a cross here. So there are 2 electrons in the first shell. You just draw the second shell, and it has 8. So you draw 8 crosses, uniformly arranged. Then you draw the third shell as well, which has only 1. Now your next step, by the way, you can write the stuff below the diagram, but it'll be better just to label it as sodium atom, just to score that mark. Then you draw for chlorine as well. For chlorine, the first shell has 2. The second shell has, let's just draw this neatly because it's important that you guys have to understand this concept. So chlorine, the first shell has 2 electrons. The second shell has 8 electrons. And the third shell has 7 electrons. 7. Oh, now the key important feature is that this diagram has been drawn with crosses. Now the examiner doesn't want to see crosses in your exam, so you have to draw it with dots. So this is a key important thing, so preferably don't lose the marks there. So first diagram with dots and crosses, this is going to be with dots. Your second and third shell should have as well. It's just going to be fast, guys. Okay, so now we have drawn the chlorine atom structure, so you can just call this chlorine atom. Now your next step to score that structure of sodium chloride is to put an arrow sign and to show the transfer of electrons. Now in this case, the sodium atom gives up its outer electron, which makes it becomes a Na plus ion, so it becomes a cation because it loses electrons. And a chlorine atom, it picks up the electron, making it a chloride ion. So this forms sodium chloride that is technically NaCl. Okay? Alright, so your next step, I'm just going to draw it here because there's no space, but in the exam you have to draw it. So you're going to, this X is going to be transferred to that side, to the chlorine atom. So you're just going to draw the diagram again with dots and crosses, but this time with no third outer shell. The third outer shell should be removed, and you should put them in brackets. Okay, now because sodium loses an electron, they become positively charged. And this time you draw a second bracket that shows a chlorine atom which has 3 shells. First shell, second shell, third shell, but remember to connect the brackets here. Put the brackets there, there's no space there. And because chlorine gains an electron, they become negatively charged. So in this case, chlorine will have 2 dots here, 2 dots there as well, because it's 8 electrons in its second shell. And this time it'll have 8 electrons in its third shell. So in this case, we draw 7 electrons at the start. This time we put a cross there. So this will score you those good 4 marks for drawing the structure of sodium chloride. Now you could mention the Na plus, you can just write down below Na plus and Cl minus. Na plus has 2 8s, electronic structure, and chlorine has 2 8 8. And you can just write there sodium ion. What I would do is I would write this concept because it's important that you write this, and you show the examiner that you know your content well. So you're saying that this is a sodium ion and this is a chloride ion. Remember, you can work out how many electrons an atom will gain or lose from its group number. So this is an important thing. So the crosses, all the electrons are identical, but this is a good way of following the movement of how the electrons are moving from one place to another. Okay, so now this is showing how the dot and cross diagrams, that is showing how the ionic compounds are formed. Just a tip that ionic bonding is just a transfer of electrons, and it occurs between a metal and a non-metal. So this is where an metal atom loses electrons to form a positively charged ion, and non-metals, they gain these electrons to form a negatively charged ion. Now these are completely oppositely charged ions and are strongly attracted to one another by strong electrostatic forces. This attraction is called like an ionic bond. Now in order to draw a covalent bond, covalent bonding is a different story altogether. Covalent bonding involves you have to use the same concept of dot and cross diagrams, but the electrons are drawn in overlap between the outer orbitals of the 2 atoms that are shared between these atoms. So basically we're just drawing the outer shells. So in this case, if we take into consideration for drawing the covalent bonding of NH3, we know that nitrogen, the atomic number for nitrogen is 7. So in this outer shell, it's going to be 5. So it has 5 electrons orbiting the outer shell. And for hydrogen, it's only 1. So we know that there's only literally like 1. So here, remember that we have 3 atoms for hydrogen, atoms of hydrogen. So what do we have to draw? First is we draw nitrogen in the middle, because there are 3 nitrogen in the middle, and you draw 3 hydrogens. Draw just 3 hydrogens. You can put a small circle here just to show that you have nitrogen there, hydrogens all placed here, all neatly, because they're overlapping each other. So the dot and cross diagrams are very useful for showing like which atoms the electrons in a covalent bond can come from, but they do not need to show the relative size of the atoms or how the atoms are arranged. So this needs to form like 3 covalent bonds to make up the extra 3 electrons needed. You don't have to draw the orbitals in the diagrams, but this is an important way that you get all the dots and crosses. But the orbitals are a nice way of representing it. So now, because there's an overlap, we know that nitrogen has 5, and it needs 3 electrons more to become 8 electrons in its outermost shell to become stable. So it has same number, atomic number, right? So it's 8 electrons in the outermost shell to become stable. So what we're going to draw is we're going to put 1 cross. Remember, again, hydrogen can use dots, whereas nitrogen has to use cross, because you're showing the difference between these two. Do not use crosses in both the diagrams. This is very key important. So we show that there's 1 bonding for nitrogen, and you put 2 electrons for nitrogen outside. So in total, there's 5. Now for hydrogen, you know that there are 3, right? 3 hydrogens, and all they have 1 electron. You just put a dot there. This will show you and give you strong covalent bonds, and get you strong marks for just showing how these form 3 covalent bonds to make up 3 extra electrons needed. Now there are different ways of representing this. You can represent this in a displayed formula, but this is a preferred method for showing covalent bonding as well as ionic bonding, and hope so this video helps. More content will be posted soon, but please do comment below. Please like, share, and subscribe. It'll help the channel a lot. And if you guys have any more questions, or you want me to solve any more past papers or questions on certain topics, please do comment below. Otherwise, I think that's it. Bye guys.